Good morning, guys. Today we are going to work on lesson 28 problem set. So before we even get started, I would like to show you guys that this problem set looks really long, but it's the way they've put all the space in it. They've given us most of what we need to solve these problems, and they're just asking us multiple things about each question. It's not a ton of extra work, but it does have one more page than what we're used to seeing. Let's look at problem 1. It says Gia measures her rectangular garden and finds the width is 9 and the length is 7. So here is my width of 9. Here is my length of 7. Now that I think about it, this is wider than it is long. I want to go and I want to correct my rectangle real quick, because we have a wide rectangle, but not a particularly long rectangle. So maybe more like that. We said it's 9 and 7 and 9 and 7. What is the area of Gia's garden? Area is length times width. We already know our length and our width. It's going to be 7 times 9, and 7 times 9 is 63. Remember, if you're having trouble with your 9s, you can always multiply by 10, do 7 times 10, get 70, and then count backwards one group of 7. So 69, 68, 67, 66, 65, 64, 63. You can always work off the 10 if those 9s are troublesome for you. All right, question part C. What is the perimeter of Gia's garden? So remember, for a perimeter, we want to keep adding up our sides. Sometimes we can confuse area and perimeter. So I will take a moment. I'm going to make sure I write out our formulas. I'm going to say side plus side plus side plus side. And then I'm going to show our work off to the side. So we have 9 plus 7 plus 9 plus 7. I'm going to take my parentheses and I'm going to group these guys so that the problem becomes easier, because I know 9 and 7 is 16. So now I have 16 plus 16. And 16 plus 16 is 32. See, I told you, these problems look really big and they look like it's going to be so much extra work, but it's really not bad at all. The questions are fairly simple, and they've just allowed us space so that we can show all of our work. I'm going to erase what I've done so far, and I'm going to move on to question number 2. It says Elijah draws a square that has side lengths of 8 centimeters. Let's see, that looks pretty square-like. So remember, when we have a square, what we want to keep in mind is that all the sides will always be the same. So this side's 8, and that side's 8, and that side's 8, and so is this one. Every time that a shape only gives you one measurement, and it's a square, an octagon, a hexagon, a pentagon, that means that all of the other sides are going to be the same. Doesn't work with rectangles, because we know rectangles are the rule breakers. Doesn't work if it says one side is blah, blah, blah. But here, this told us side lengths. We had that S hanging there on lengths of 8 centimeters. All right, let's look at part B. What is the area? Again, our area formula, length times width. So that's 8 times 8. And 8 times 8 is 64. So it has an area of 64 centimeters. For a perimeter, we're going to add up all of our sides. So we have side plus side plus side plus side. So we have 8 plus 8 plus 8 plus 8. That is repeated addition. And instead of writing 8 plus 8 plus 8 plus 8 plus 8, I can take an easy way out because there are 4 sides that are exactly the same. So when I know all sides are the same, I can multiply the length by the amount of sides. Because 8 times 4 is the same as 8 plus 8 plus 8 plus 8. It is the exact same set of measurements, but instead of doing all that, I can just do 8 times 4 in this instance. Notice that we had the same perimeter for both parts of C, which I thought was kind of fun how they had that repeat again. All right, Elijah connects 3 of his squares to make one long rectangle. Let me see if I can connect my squares nicely. Wasn't a perfect connection, but that's okay. Like we always say in class, people aren't perfect. Maybe I can fix this one. Better. All right. We have connected 3. We know this one is 8. We know this one is 8. And we know this one is 8. I have not changed anything over here. I haven't connected any other squares. So this side is going to be the same. Let's take a look at what's happening up top because we have 3 things that are 8 squished together. 8 and then 8 and then 8 more is going to get me a total length of 24 because I combined 1, 2, 3 squares together that have a measurement of 8 centimeters. Part D wants to know what the perimeter is of this new rectangle. I'm going to label my other side. I'm going to cross these guys out because we know this top part is actually 24 now. We've solved for it. And this side is 8. All right, let's do 24 plus 24. This is nice. There's no regrouping. So we just end up with 48. 8 and 8 is 16. So I'm going to add here, and here I will have regrouping. 6 and 8 is 14. Carry my 1. 1 and 4 is 5, and 1 more, 64 centimeters. Let's move on to question number 3. The area of Mason's rectangular painting is 72 square inches. So I know our area is 72. The width of the painting is 8. So we've labeled the sides we know. We have mystery sides right here. So going back to our area formula, we know it's length times width. We've got our width, but we don't know what our length is. So area is some mystery length times 8, and that something times 8 gets us 72. So we have to think, how many times can we fit 8 inside 72? In order to find that missing side, I'm going to divide 72 by 8. I'm going to give you a moment if you need to skip count and use your fingers, if you have to pull out one of your multiplication charts. So when we divide this, we should find the answer is 9 centimeters. Oh, excuse me, we're on inches now. I said the wrong thing. My bad. 9 inches. All right, part C. What is the perimeter of Mason's painting? All right, I'm going to group my width together, and I'm going to group my length together. And so that gets me 16 plus 18. And 16 plus 18 is 34. So his painting has a perimeter of 34 inches. All right, scrolled a little too far. Mason's mom hangs the painting on a wall that already has 2 of Mason's other paintings. The areas of other paintings are 64 inches and 81 inches. All right, I'm going to label the one we know. We said it was 8 by 9. This is 72. I'll make this my 81. And this is my smallest, so I'll make it my 64. What is the total area of the wall that is covered with Mason's paintings? So on this problem, it is really tempting to make this very complicated and to start trying to figure out what the missing lengths are and look for your sides. Maybe you have this urge to multiply something. You don't have to. For part D, all you need to do is add up the areas. That's it. We need to add 64, 81, and 72. So I'm going to add 64 and 81 over here, and then I'm going to add 72 onwards. As you know me, I always start with 2 and do one more. If you want to triple stack your numbers, go for it. It's whatever works best for your brain. I like doing things in stages because I find that it is easier for me to make mistakes if I have too much going on at once. So now I'm going to add my 72. All right, 2 and 5 is 7. 7 and 4 is 11. I'm going to carry my 1 and stick them right there. 1 and 1 more is 2. So 217 inches of Mason's mom's wall, that was a tongue twister, are covered in paintings. All right, the perimeter of Jill's rectangular bedroom is 34 feet. Perimeter. So perimeter. They added all of the sides. So we want to estimate and label the side lengths. So I'm going to go to our strategy. We're going to do 34. We're going to divide it by 2. All right, 2 fits into 3 one time. If I have 3 seats, I can definitely fit 2 people in there. I can fit one group of 2. This is the part that we were still working on in school. So I'm going to be very slow and explain everything that I'm doing here. I said I can fit one group of 2. My 1 will go over my 3. This is the number I'm dividing by. This is the number that is getting divided. I am going to write the 2 underneath. 1 times 2. I put that right here. And I'm going to subtract. 3 minus 2 is 1. I know y'all are looking at your screen right now and you were like, Ms. Hagelberger, please stop. We only started this. This is going to keep making more sense. We just need more practice with this. By the end of the year, you're going to be like, and you're going to go into 4th grade and you are going to be so ready to divide. So again, I said 2 fits inside of 3 one time. And this is where it gets funky and y'all always look at me all kinds of crazy. Then I'm going to say 1 times 2 is 2. I'm going to take it away from my 3. I'm going to bring down my 4. Why am I doing that? Because that 4 is hanging out in space and it needs a friend. It wants to be friends with the 1. And now I'm going to ask myself, how many times can I put 2 inside of 14? If you went, oh, that's 7, you are awesome. Good job. It is indeed 7. So now we know that both sides are going to add up to 17. I can pick any group of number, any 2 numbers I want that will add to 17, but I'm going to keep in mind this is a bedroom. Bedrooms are usually almost as wide as they are long. So I do not want to give poor Jillian a 2-foot wide bedroom and then have it be 15 feet long. I want to try and keep them even. So I'm going to say this is 8 feet and this is 9 feet. I'm going to stay away from labeling over here where I've divided. I'm going to tuck it up here in the corner. I don't want to mix it up with what where my work is. All right, so we are going to say that the width of her bedroom is, whoa, whatever squiggle that was trying to be, 8 feet. Now they want to know the area. So we are going to do length, I just wrote the width, length times width, which is equal to 72. All right, let's look at part D. It says Jillian has a 4-foot by 6-foot rug in her room. All right, so here's her room, and there's the rug. So it is 4 feet by 6 feet. What is the area of the floor that is not covered by the rug? That is not covered. We want what is not covered. We want the part of the floor that does not have rug on it. So to find that, we're going to say what our area is, 4 times 6, that's 24. We know our total area is 72. I am going to subtract what the rug covers from the total area, and that will tell me what the rug does not cover, because we are looking for the part of the floor that has no rug, bare feetsies. All right, I cannot do 2 take away 4, so this becomes a 6. This becomes a 12. 12 minus 4 is 8. 6 minus 4 is 2. So 48 feet of her room do not have rug on it. If you go and you only tell me the area of the rug, you did not look at your keyword, which was not. We want what is not covered. All right, and that was the end of our problem set. See, looked long, wasn't nearly as bad as we thought it would be.